All right, let's begin. So to cover the thing I didn't specify 2 weeks ago, the alarm attorney no longer calls multiple functions to trigger the alarm. So instead of having the deregistry and then triggering alarm 0, now the deregistry happens within a trigger alarm function, and then I trigger the alarm within that same function. So the alarm attorney only does one call now. Other than that, let's begin. So for this week's assignment, we had to set up the framework for collisions. I ended up testing it similarly to how I tested the inputs with registry and deregistry. So right now, if I run this, the frigates collide with each other and the axis, and then stops, it starts, it stops, and starts, all based on that alarm. If I were to swap scenes, we can see there's no more frigate calls because the frigate is not part of the scene, and then the cubes are colliding with each other. Then when we swap back, frigate collides with axis itself, stops, starts, stops, and then starts again. No leaks. So for how we set up the collisions, we have the set collidable group. This set collidable group determines what the ID for a given type is for a given class. So when the frigate calls this, we get the manager and we get the collision ID. So this uses a static local variable. This local static variable will increment the next number so that every different class that calls this will get a unique value. But if a class calls this multiple times, it will always return the same value. So all frigates calling this would get 0, all axis would be get 1, etc. Once we get our ID value, we call the group type. We call this function will check to see if the ID already exists within our collection of groups. If it does not exist, we create it. Otherwise, we just ignore it. And that's how we pass through the creation. Within the registries now, if I were to request register, it will pass itself through the scene as all of our other examples do. And when it's time to register the object to the scene, we get the collision manager, get the ID, and then register it to that collision group. The collision group will then insert it into its list and then pass through the reference to the object's position in that list for the quick insert and erase method that we do. And that's how we register. Um, Within our scenes, we have to determine which collision types we want, whether it's a pair or a self. So we have collision pairs and collision selves. These will call this temptized function, which passes all the way through to the collision manager to handle the different types of tests we can do. So for collision pairs, we take the two type names, get the group at their ID, and then create a dispatch template between the two groups and push this new test pair onto our list of tests. For self collisions, we get the group at that single get the single group here. Our dispatch is still a pair, but it's a pair of the same type name. So collision of frigates against itself, it's a frigate against a frigate, and then we push it onto our list. In the scenes update, we call the processing elements. This will go through our list of tests and execute the collisions. If it is a collision between two pairs, we get the group, we get the collection at that group, and then we do a nested for loop to test each object 1 against object 2, and then we send the collisions that way. Right now it's always a guaranteed pass, so no extra work to show there right now. For the self, we have to do the same thing but slightly modified, so it's still a nested for loop. However, we determine the inner for loop by getting the outer for loop's index and incrementing it by 1. This makes sure that we don't ever collide a frigate with the same identical exact copy of the frigate, and it will also make sure that all of our collisions are unique. And because of that, we also have to make sure our inner loop is 1 smaller than the outer loop. For the template call, when it's time to send the collision for either of these, they call this templatized class. It takes the two type names that we give it and will static cast the objects and call the associated collision. And that's how collisions are handled. For the tank demo, I added a new purple tank. This purple tank will get the player's position and determine if it needs to move forwards, backwards, left, or right. So as you can see, if I were to get behind them, they start moving backwards now, and they're trying to move towards my position. If I were to go behind them the other way, we can see that they start turning the other way. If I stay in front of them and then turn this way, we can see they turn that way as well. So to do this, we get the vector between the 2 points, the points being the player's position and the current tank's position. We do the dot product for the current tank's forward vector, dot product that with the vector we got above, and then do the dot of the above vector against itself. And then if this value returns negative, we need to move backwards, otherwise we move forwards. And then to determine the rotation, we do the same thing, except instead of the forward vector, we do the left vector. And that's it.